My name is Hirofumi Tomita, the team leader of the climate division team in AICS. My talk is about the future regional climate change. And so the title is How does the regional climate assessment make more advanced? Regional climate assessment is not yet established, I think. I will talk about and introduce a new method, new concept and a new method. If you have a comment, we appreciate very much. Okay. So what I will talk about. First, I will introduce the assessment of regional climate change. How does regional climate assessed? And in this assessment, we take a downscale technique by a regional climate model. I also mentioned the merit of regional climate model. Key is the how to treat a boundary condition of RCM. RCM means the regional climate model. That boundary condition obtained from GCM. GCM means the global climate model, so global model. And what is a climate aspect we should take care of if we assess the regional climate change. In this talk, I explain the lack of previous or conventional assessment methods. And after that, I talk about the introduction of our concept. Main issue of this talk is how should we improve the assessment method, conventional assessment method. Recently, our team work is very excellent. Based on the paper Adachi et al. 2017, also Nishizawa et al. 2018. The key point is we dare to use the merit of RCM more. So merit is also demerit, but I use that property of RCM positively. Okay. Finally, we summarize, but this is debatable issue. So how can we apply to this method to another problem? This concept is very, very simple about and applicable to the another field. This is a debatable issue. Okay. What is the regional climate model? The method of RCM is almost same as the global climate model because the equation system is almost same, but modeling is somewhat different. RCM is more sophisticated than the global model. And there are two advantages of using RCM over GCM. To obtain regional climate information with fine spatial resolution based on more sophisticated physics. This leads to the added value over the GCM. And also, we can extract the regional climate response to a specific constraint given as a boundary condition. RCM inevitably need boundary condition. But this is merit, but also demerit. And as I mentioned, I dare to use this property as a merit. So this is one of the constraints is large-scale atmospheric condition. Okay. So what is the downscaling? So first, we conduct a global climate assessment. So typically, there is many results obtained from the IPCC report. And also, the boundary condition for local area is constructed from GCM result. And using this boundary condition, temporal and spatial detail is simulated in the local area. This is a regional climate model mission. And in this model, we can consider more realistic situation in this model. For example, find spatial scale atmospheric process, and also spatially detailed topography, and also land use. This is added value. And after that, so that information is provided to the stakeholder. So they will assess the impact using our scientific result, and they will design the adaptation plan to future climate. So the mission of RCM from the viewpoint of social demand. So RCM is a kind of a translator and bridge between the global climate simulation and the stakeholder. Okay. And so I will explain the advantage of a regional climate model. So as I mentioned, so from a global climate model, atmospheric condition with coarse resolution is obtained. So which is the temperature, wind, and humidity, or something like that. And RCM, we conduct the RCM by this GCM boundary condition, adding a spatial detailed topography and land use data. So by changing boundary condition, so we can know the response of regional climate to the change in boundary condition. Okay. This is the merit of advantage of a regional climate model over the GCM. So the big issue is what is the dominant factor in future regional climate. So if we evaluate dominant factor, so we can construct the boundary condition from the obtained from the GCM divided so some components by different time scale. So what are the change of atmospheric component associated with the global warming? So one is a change in mean state of atmosphere. So so increase of greenhouse gas leads to the temperature warming and also increase of water vapor. And as a result, change of atmospheric radiation balance. Okay. And this is true. And also, the other component is perturbation. Perturbation is defined as the fluctuation from the mean state. Okay. And this, so for example, so we can image here, this change is a change in frequency and the track of a typhoon or mid-latitude cyclone, something like that. So final picture is some schematic figure. Okay, so we divide components, climatology and perturbation. So here, so we can image the climatology as a monthly mean atmospheric state, and also perturbation can. Perturbation is, for example, synoptic scale low or pressure system, and also tropical cyclone. So what do we do using dividing technique? So before this, our colleague Nishizawa explained here very excellently in phase space. So this is a schematic diagram of the large-scale state driving the downscale simulations. So he also categorized the existing method into the phase space of the climatology and also perturbation. Okay, and we usually use the downscale technique. So as is. That is a direct downscale. So in this simulation, we use directly GCM boundary condition. This called direct downscale. And so this is a present DDS, and this is a future DDS. And also, one famous and one well used method is skewed climate downscale. And this is using only the difference of climatology only from GCM. So those methods consider only the climatology change except for the DDS. Okay. So what is the previous? What is the lack of a previous study? The direct downscale is constructed by using a boundary condition from GCM as is. Okay. So including both of components, but it cannot separate influence of us, each component change. So two components contaminate each other, the result. Okay. So we cannot extract the each of influence. On the other hand, the pseudo-warming DS method is very useful and well used. But it does not consider the change in perturbation, as I mentioned. So I think in history, many people so far think that the mean state change is dominant factor on the regional climate. But recently, the significance of perturbation change is a debatable issue. So this is a very important issue. So our motivation of this study is a new evaluation method estimating influence of climatology and perturbation change. So separately is needed. So this picture shows our new assessment method, schematic figure of principal concept. So delta red is total difference. In this picture, example is precipitation. So this is the total difference from future to a present climate. And delta C is a contribution of climatology change by just changing climatology, so climatology difference. And also delta P is the same way contribution of perturbation change by changing the only the perturbation difference from present to future. So important thing is if the system is linear, we can easily expect the future change, future difference, future change of precipitation by summing the delta P and the delta C. But the system, unfortunately, nonlinear. So, contribution of nonlinearity between the two components change is existing. So in this picture, show the delta CP is the contribution with nonlinearity. So this part. Okay. So we conducted two DDS and also two artificial boundary condition used. Okay. So this is the experimental design for demonstration of the procedure. And first two is DDS, direct dynamical downscaling, and also direct dynamical downscaling for present climate and also future climate. The latter two is pseudo climate change, in which we use boundary condition. Future climatology and present perturbation. And also pseudo part of DS, we use present climatology and future disturbance. Okay. And we prepared climatology and perturbation data from the MRI, Meteorological Research Institute, AGCM, for present and future climate. And we perform 4 experiments. Okay. And so our team developing regional climate model, scalable computing for advanced river and the environment. We call it scale. And this model is freely available. You can visit this homepage. Okay, this is first result. This shows the map of future change of daily mean precipitation. And we can see this is the present DDS and this is future DDS. So this, the difference between them is a total change here. Okay. And also we can evaluate the delta C. That means the result by changing just climatology. And also delta P can be obtained. So as I mentioned, so delta C and delta P is expected climate change. So and we can see in this case, so perturbation change explain most of a future precipitation change. Okay. And this picture shows the summation over the domain of precipitation index and contribution of each component. Okay. So left figure show the daily mean precipitation, and right is the maximum one-day precipitation. So typically, this is the mean value, and this is extreme value. Okay. And important point is here. delta C and delta P represent the expected climate. That is linear system. And this sign and also interaction sign is the same. In that case, interaction enhance the expected climate change. Okay, so this is typically this situation is typically shown in this picture. And if expected climate change sign of expected climate change and the interaction is different. So interaction suppress the expected climate change. And in that case, this picture is typical in this case. Okay. So in this demonstration, the future precipitation change cannot be explained only by the contribution of climate change. This is a very, very important conclusion. Okay, this is summary and discussion. And symmetric treatment of both components, climatology and perturbation, is very, very important. So the contribution of perturbation change is larger than that of climate change in mean precipitation in this case. Okay. And the nonlinear effect has a significant influence for extreme precipitation. And so I have to mention here which is dominant depend on the area, so specific area, so target area and evaluate quantity. And also, second summary is the procedure could provide clue to the mechanism that cause the future regional climate change. And the precipitation increase due to climatology change is mainly caused by thermodynamic change. That is so-called crisis climate effect. And it is true in our experience also. And the precipitation decrease due to perturbation change is related to the change in activity of disturbance. And it is occasionally have a strong effect. This conclusion very, very important. So in the future, so this method can apply to other problem. So I think so, because this concept is very general and very simple. So one application is the direct application for using many GCM results for downscaling. So if so, we can extract the uncertainty source, which is the dominant uncertainty source. Okay. And also, any to change, here we consider the climatology and the perturbation, but any to change can be set as a constraint of the regional climate boundary condition. So this is, I think, a promising method for other issue. Okay, thank you very much. So.